This is BSA by Design, a podcast about transforming healthcare, educational, and research facilities through expert design and insight. I'm your host once again, bmoore. In this episode, we're diving into something most people never see in a hospital, but it absolutely depends on: the boiler plant. And in Florida, that conversation gets especially interesting. We will be talking about boilers, backup fuel, and decarbonization. Let me introduce our guests, Rick Wilkins and George Stefanovich. Rick Wilkins is the Vice President of Thermaltech, Inc. He manages day-to-day operations of Thermaltech's Jacksonville office and has been with the company for 31 years and has over 40 years of experience in the industrial and process design and construction, boiler, and HVAC marketplace. Rick graduated from Georgia Tech with a BS in Mechanical Engineering and has a Florida PE license and a Florida Certified Mechanical Contractors CMC license. George Stefanovich is a principal at BSA and the Tampa studio director. George has been in consulting engineering since 1996 and has worked on various projects in different markets, primarily healing, healthcare, mission critical, and learning/educational. Rick and George, welcome to the show. Thanks for joining me.
Yeah, thank you for having us.
And I'm excited to talk to you both today. And as first-time guests on the show, I always like to find out a little bit about our guests. So tell us, how did you get here? What's your background like? And Rick, we'll start with you.
Well, I said I've been with Thermaltech for 31 years, actually going on 32. So the first 31, I was in Tampa. That's why I edited to show it in Jacksonville now. We just moved up here. And I thought about that this morning. It's been, in the next month, it'll be a year. So I've been up here 11 months. And it's difficult starting over at this age in a new market. But I'm doing the same thing here with Thermaltech as I did in Tampa. And prior to that, we are boiler manufacturers, reps, so sales, service, and parts. I primarily deal with the HVAC CapEx space. That's where I know George. Early design of new jobs, equipment selections, systems, everything that goes with it. But prior to that, in the Carolinas, what my wife calls BC, before children, I was in the consulting space, but primarily purely industrial. Floor Daniel is a large group out of Greenville, South Carolina, and clients were all in the food and beverage space, the chemical space, the pharma space. So things like healthcare and commercial work were not on my bailiwick up there. It was primarily process, which is all the steam and chill water and hot water and gas and fuel and you name it. So the equipment I got familiar with through the consulting process is everything we use in the daily type of systems here with HVAC.
George, how about yourself?
Yeah, it's a pretty simple story. So I'm from Romania originally, but I came to the state in 1996, and I have been so fortunate to get here, and I worked with the same company since 1996 until 2023. And as you know, BSA acquired the Carastro & Associates engineering firm. So been very fortunate to be with the companies, and today to be with the company that I'm with. Fantastic companies, and fortunate to work in. Was primarily healthcare, but we did do a little bit of everything. So with Carastro, we did a lot of healthcare and a lot of mission critical, and a little bit of everything else. We did educational and office spaces and whatnot, industrial and so forth. The one bit I don't know if I ever mentioned is that I went to college for thermal. I think the translation would be thermal machines. Okay. We had 3 sub minors. So internal combustion engines, every boy wants to be internal combustion engine specialist type thing. And then turbines and refrigeration. And I chose not to go to refrigeration, came to the States, and that's what I'm doing.
Sounds like, based on the topic that we're going to talk about today, designing for resilience, boilers, backup fuel, decarbonization, I've got the right people on. So that's exciting. I appreciate those intros. Rick, how has the boiler industry changed since Thermaltech started?
Going back into the late 80s, early 90s, there was no such thing as a condensing boiler. That's new. We were late to the technology change. If you look at what Trane and Carrier and York and Daikin all did, their controls for chillers, it started to morph into the PLC type controls way early on. That's a new type of thing for boilers. New being, the last 15, 20 years, but it wasn't, it was still switches and mercury bulbs and controls like that. RWB, which is what it's a slide wire proportion. Chillers don't do that.
Yeah, right.
That was new. But a boiler is still a boiler as far as the basic design from at least the manufacturer I represent: fire tubes, water tubes, refractory. It is the burner technology that has improved because of emissions, and the controls technology from parallel versus single point type stuff. That's all improved efficiency. That seems to be, and now the trend is HVAC reheat from hot water versus steam, but boilers are still the biggest change, I think, has been in the controls and emissions type stuff.
What makes Florida unique compared to other markets?
I don't think there's anything unique about it other than their perception. I am from Baltimore originally. And when I go home and I used to talk to classmates at these reunions, and they look at me like I had 5 heads. You're doing what in Florida? Boilers? And this just happened the other week. I was sitting there with a group. They do parking lots, and they're like, what's boilers in Florida?
Boilers in Florida, yeah.
And then we started talking about the food and beverage industry and the healthcare industry and just various things that steam/heat is used for. They're like, oh, okay. And I said, you guys do asphalt.
Right.
We don't do boilers for asphalt, but we do burners, right?
Mm-hmm.
To help melt that stuff. Different type of boiler. Seasonal effects. We really don't have a season down here like you would have. People get prepared for winter up north on their boiler operations because they're not operating during the summer. Here, it's nonstop. If you're not doing sterile, you're doing HVAC reheat, or you're making domestic hot water. It just doesn't stop. And we're sea level operations, so we don't have to worry about derate. So that's not unique. It's just we're not in the mountains type stuff. Humidity, it's in the air. It changes the density, but you don't really see that in combustion. Nowadays, you can tune that. George.
My first reaction is the same. Northern climates versus Florida. Again, kind of a reaction to say maybe we don't have as much industry as other zones have, but sure enough, we have food and beverage. And as a matter of fact, Rick reminded me of that not too long ago. So yes, it's kind of a natural reaction, I feel, as a Floridian. You seem to associate it with cold weather.
So how do boiler system designs impact hospital performance, George?
So I would start with the efficiency. Really, I think it's top of mind these days, and for maybe recent years, whatever that is, 5-10 years, people think more of that. And along with it is, I think maintenance is often forgotten. And it's so important to have. And it's not necessarily the complexity of maintenance on one versus the other, steam versus hydronic, but what I've seen, similar to other aspects of our industry is the skilled labor. You need someone who knows how to handle a steam boiler or a hydronic boiler for that matter. Right. But the knowledge in certain type of systems, and steam unfortunately seems to be one of them, is being lost over time. It's just hard to find technicians. With the steam system, the piping has to be a certain way, the welding, the insulation, and on and on. But I would say efficiency and maintenance would be the top reasons. And the hydronic boilers, as I'm sure will come up later in our discussions, are just more efficient and maybe simpler to maintain.
You mentioned the efficiency because it's fuel cost. So there's the capital part of it, but then there's the operational cost for any facility. And I did this years ago, just flip the coin type thing. But if you spend X for a boiler, a new plant, you're going to spend 3 times that every year on fuel.
Wow.
And that's gas fuel, not electricity.
Right.
Because electricity is even 3 times greater than that. So it comes down to efficiency. And there have been cases where a bean counter finally gets the message that, hey, so-and-so low bid is $250,000 cheaper than you. I'm going to go this way. Wait a second. What is that efficiency versus what I'm offering at higher price? And how quickly can you pay back that delta because of the efficiency? And in certain cases, that has won the award for the not low bid.
Ownership cost.
It's a 30-year piece of equipment, and you can pay back a delta in 5 years. It makes sense to not go with a less efficient plant
And we're definitely gonna jump into some of this too. George, why do you think this is such a critical conversation for Florida healthcare? Is there anything that's unique about it?
I think it's important everywhere, but I think Florida, once again, that climate comes to mind that we don't have those tremendous loads. We're dealing with, Rick mentioned already, it's a nonstop operation in a hospital. You have the kitchen, you have the steam needs in a hospital, the process needs that seem to be maybe less in certain aspects, maybe less than in the past. So it is important for that specific reason, as in, again, simplicity and simplicity of maintenance. And then the first cost. Unfortunately, a lot of people are, and we're going to touch on this again, people are still looking at first cost, but the total cost of ownership. So Rick
Right.
has just mentioned 30 years on a steam boiler. So anywhere from 20 to 30 years, a life cycle cost analysis should always be used to reach that, to find out what is the best system to operate.
So it's my understanding that these steam systems have historically dominated healthcare. Why were steam boilers historically the norm in hospitals?
I would go back to what he pointed out in the simplicity of the piping infrastructure. If you have a steam plant for sterile and a hot water plant for HVAC and another hot water heater for domestic, you have now, depending on the redundancy, 6, 8, 9 pieces of equipment that are all scattered everywhere. Steam, you get a single piece of equipment plus redundant, make the steam, and if you control the steam pressure, you control the steam temperature. That's why you see sterilizers operate at 30 psig to obtain 274F, whereas you can generate steam at 100 and transport it all over the place and then reduce at your point of use to what you need. And it's one pipe out and a condensate line coming back, which we call liquid gold. Ideally, you want to capture that and dump it. And then from there, it's a heat exchanger, which is a lot less complicated piece of equipment versus another boiler per se.
George, do you think any of that was influenced by northern design firms doing projects in Florida? And what were some of those advantages at the time?
I definitely think so. This time, I don't think it's just perception. So, as I was starting my career 30 years ago, I noticed that I was fortunate to do a lot of work in various markets and various buildings. And I noticed in the big project, we were doing renovation work in a hospital, in a big campus, and we were working with original design documents. I saw over and over again, you see names from outside Florida. So the original designers really were from outside Florida, I think, in many cases. And I think the explanation is simple. They just didn't have the firms with the knowledge. People still felt more comfortable with big names from outside Florida. Sure. And then those companies, come in and they do what they know best. Not that the system is, like Rick said, there's absolutely nothing wrong with the steam system, for example, but you do what you know that works and what you think is best at the time.
So, Rick, can you walk us through? You've mentioned a few pros already about steam boilers. Any more pros, any cons that come to mind about these systems?
Well, I just mentioned one type of equipment for all uses in a healthcare facility: sterile, cooking, heating type stuff. One piece of equipment. You see, I have pressure and temperature control. And cons. It would be what George pointed to. There is a lack of skilled labor for an operator in the area. And it's not just Florida, it can be other states, but there is if you get into federal government, there is a requirement for a 24/7 attendant called a stationary engineer. That whole thing was dropped in 89 in the state. And I think Hillsborough County was the last holdout in 1991 or 92, where they required an operator, a stationary engineer's license. That doesn't exist. Therefore, the skill has dropped. Water treatment is critical. I hate to say it, but I've got an acid cleaning going on right outside my window today because of a boiler that came back on red was totally scaled up and fouled up internally from lack of, if I will, blow down / water treatment. It's 90% of our work as a result of a lack of proper water treatment. It's just water's hard in Florida.
Right.
You don't get that critical. And that's in steam systems. If it wasn't a steam system, like a hydronic system, that's supposed to be closed loop, no makeup water unless there's a leak. And you don't have the issues with the water treatment, criticality, and the skilled operators.
Let's talk a little bit about hydronic boilers and what separates them in terms of efficiency and other advantages, from steam boilers.
Right off the bat, you're always going to have a delta T between the flue gas exiting, the products of combustion go through the boiler and exit the stack. There will always be a delta T between the leaving exhaust and the water or fluid you're heating. So since you're dealing with water versus steam, the fluid is a lot lower in temperature versus a steam temperature at higher pressure. So naturally your stack temperature is going to be lower. You have out of the box 2, 3, 4% efficiency gain just in a non-condensing boiler. You jump into condensing boilers, you increase it by another 14%, from the aspect of condensate in the flue gas. You hit the dew point. You can drop all those latent BTUs right back into the fluid stream as opposed to putting it up the stack.
In what applications do hydronic boilers make the most sense?
The trend we're seeing, and George, you can probably back me up on this, is that new greenfield facilities, if we're going in Florida, if you want to say something unique, is that we have what they call a reheat boiler load that is probably 6x what the sterile load is. So instead of installing steam boilers for whatever, just a factor of 8 to handle sterile and reheat, put in the small sterile boiler, and they can be electric, that are self-contained on the sterilization equipment that people sell, and there's no steam boilers. The sterilizer makes its own steam, and now you have an HVAC hot water plant that the last couple ones we've done, $4.5 million was sterile and 24 million was reheat. So now all of a sudden you're working with a large majority of equipment being the more efficient hydronic boilers. Therefore, your fuel cost just went down because your efficiencies went way up, especially if you go condensing.
I think you were describing a hospital application, but applies to other, excluding industrial. When you get into the food industry and other industrial applications, that's exactly the balance that Rick mentioned between steam process steam load versus reheat, domestic water, whatever other heating loads one may have. And if it wasn't clear enough, a couple of other differences I would point out. Rick already mentioned the simplicity in steam is one of the advantages is that piping sizes are small because they have high pressure steam, even medium pressure steam. So it's a relatively small pipe, and then the condensate return. So 2 pipes. Now, when we're talking hydronic heat, chances are you have larger pipe, maybe much larger pipe, both on the supply and the return. I would say you make up some of that difference, especially these days. The industry adapts, the markets adapt to demand. So the insulation, a good insulation on a steam pipe is significantly more expensive than the typical installation on a hot water pipe, hydronic pipe.
Good pipe.
Although we're mentioning different sizes of pipes, I still think the insulation, and once again, I emphasize good insulation on steam piping, would typically be more expensive. So in any new construction, we seem to see hydronic as the way to go. Rick mentioned the difference between the steam load versus reheat load. And I would also point out that a lot in hospitals, again, we're talking about it, a lot of the specialized medical equipment has point of use steam. So yes, we could have a boiler, and many times we do. Sometimes we don't even have that because the medical equipment is self-sufficient and it produces whatever it needs.
So George, where should hospitals maybe avoid using hydronic boilers?
Nowhere. The immediate question would be nowhere these days, but it is a project by project, application by application exercise. Large sterile processing departments, maybe large kitchens sometimes, or any significant load that may require steam should be analyzed. That may lead to that decision. I think the majority of the heating production should be through hydronic boilers these days.
So from both of your perspectives, is this a philosophical shift or a performance-driven one?
I'm thinking performance.
Performance by far. We learn and we adapt. We are aware of the effect of the combustion results and efficiencies and so on. That definitely performance-driven.
Interesting.
That goes back to one of your former questions. What's evolved and changed? These newer boilers with their better emissions and lower
Better
fuel,
performance.
better performance. It's just better all around. It's market driven, not so much government driven.
Okay, so let's shift a little bit, and I think this is timely given what's going on in the world, but diesel fuel oil. So I understand historically this is common primary or backup fuel and has storage footprint advantages over, say, propane. There are some regulatory and environmental implications. So, Rick, what's involved in maintaining diesel backup systems?
I've been on job sites and seen the equipment that we have to draw from and return to, especially when startup doesn't go as planned and things aren't working. First of all, you have like 12,000, 15,000, 20,000 gallon tanks. They used to be buried. Now you cannot do that anymore. They're above ground. So that issue about space and footprint may be a misnomer on my part, but those tanks are also double walled. So they are contained a tank within a tank, leak detection in between the walls. Now, in addition to the fuel storage, you now have the piping to and from the piece of equipment, just like in a chilled and hot water system, a steam system, a propane system you're going to talk about is one way. This has return. There's also the issue of if you don't consume it, think about what happens to the gas you keep in your garage.
Right.
Been there for a year. The gas, it's Florida. You're going to get moisture in there.
Yes.
So now you have contamination of the fuel. It's not that you can't use it. It's just that it might not have the BTU content, or you're going to have a burp somewhere in your line relative to a piece of equipment trying to draw that. And it should be exercised regularly. You just can't let it sit there for a year and all of a sudden say, hey, here comes a hurricane. Let's go out and turn this thing on. Well, if you haven't done that, you might find yourself in trouble. There's piping. There is pressure regulating as well, because there's certain things you can't do in a boiler room relative to supply pressure. You have to reduce that pressure for consuming at the piece of equipment. And then back to the tank you go and circulate. So same thing, pumps break, pipes leak, kind of stuff, right?
Those things happen, right? Is using backup fuel just a good practice, or is it sometimes mandatory?
For hospital and healthcare, it is mandatory.
Correct. That is correct. It is mandatory.
And
I think there is a difference.
Yeah.
And the amount of fuel is, there's a legal aspect of it, how much fuel you should have as a backup source. And the other aspect of it is, and I need your help on this one, is the requirement of exercising the equipment on the backup fuel or not. So obviously it's good practice. Obviously every facility and every reputable facility engineer knows that, and they would want to exercise the equipment. However, if it's not code required, then maybe you'll run into some situations where people don't exercise it and then run into problem. I think the past discussion, Rick, I think you mentioned that there are some instances where it's absolutely required to exercise it.
Yeah. And what comes down to is emissions reporting.
Oh.
And that if you run for more than X hours a month, or you consume more than so many gallons of fuel oil per month, you're now into a reportable situation. Whereas, so now, yes, you have to exercise the equipment, but as I recall, correct me if I'm wrong, if somebody knows, if you run on diesel fuel for more than 8 hours a month, you now have to start keeping records of what you've consumed, and that gets turned into your local DEP or EPA type stuff.
Yeah.
So yeah, the hospital should exercise the equipment, since we're talking healthcare, to maintain its operational type readiness. But at the same time, you can only run them so many hours before you now have to get into more paperwork, which nobody wants.
So, George, what's involved when you're switching fuels, steam versus condensing boilers?
The challenges come when you come back from the backup source to your primary source, which is typically natural gas. I don't have the details. Rick will help me with this. What's required on the boiler itself, what kind of maintenance, what kind of cleaning has to occur. But I do know that on a steam boiler is simpler. So burning diesel, or after burning natural gas, going back to natural gas is definitely simpler. No concerns there. When you get into condensing is a far more complex process. It pretty much requires shutting down the boiler and cleaning all the parts pretty much. So, Rick, how involving is that process, would you say?
Yeah, you hit the nail on the head. If you're in a steam boiler or even a non-condensing hot water boiler, going from diesel to gas is it's flip the switch. Even in the wastewater plants, when you go from digester to natural or whatever you have as secondary to gas fuels, it's flipping a switch and it can do its thing. Once you start getting into condensing boilers, first of all, if you're going to diesel, you have to raise the loop temperature up of the hot water system to above the dew point of flue gas. And if you're burning natural gas, dew point is sea level ambient temperatures. Dew points are around 132 F.
Okay.
With when you have combustion tuned in at normal, 20% excess air levels, etc. Now you cannot run in a condensing mode when firing diesel, only because it's you have sulfur bound in the fuel. No matter how much you try to refine the diesel fuel, sulfur is an aspect of it's fuel bound, there's green and red. One stationary, like for generators, the one's over the road. What we use in a hospital and over the road, obviously, is the super low sulfur. They don't do that for hospitals or anybody backup generator fuel. So you have sulfur in the fuel. If you condense that, now you have sulfuric acid. And even though you have impervious stainless steel and exotic metals, that sulfuric acid is going to eat something in some way, shape, or form over time.
I don't know much about it, but I know it does that. Yeah.
So now you have to raise the temperature before you switch. And you can run, as long as you're not condensing, you can run on number 2 fuel oil as the backup fuel or whatever, fire it to get you by for a period of time. Now you're going to go back to gas because everything returns. You can drop the loop temperature back to where it used to be. And that's where, if you have any residuals on the steel, you're going to start sweating and you're going to start making that sulfuric acid from the residual. So ideally, you should be cleaning the firesides after running diesel, but I'm not sure how many people do that. Again, it gets back to the maintenance staff, number of people that can do that kind of work, get you into trouble.
Geez, there's so much going on here, George. When you're advising a hospital client, how much does all that operational reality factor into their system selection?
I think it does. And I think the more you talk to them, the more you explain, I think you open their eyes, and whether they admit or not on their operation, on their facilities, and I think they quickly see the benefits. So the efficiency benefits are immediate. I've noticed how quick of a sale that is, that no one is questioning that. It's pretty much common knowledge these days. But on the maintenance side, I think people are obviously reluctant to admit if they don't do the proper maintenance. And as Rick said it, you probably don't see that on day one, a week, or a year, or 2 years, and then your boiler fails. And maybe it gets back to Rick's warehouse there for a deep cleaning. So yes, I think we'll see more and more of that as the word spreads. We do have currently a project. Come to find out that it's not the first project for this organization. I wanted to take that. I was really proud about it. It turns out we might be number 2, but it's number 2 after a break of 20 plus years. So obviously the previous attempt was, or installation rather, maybe they didn't quite get to the bottom of it to see the benefits. So we will be, with this current project of ours, we will be, I think, easily compared to 2 other new facilities, and I expect to see some huge improvements.
So I understand propane is an emerging innovation. And Rick, I'm going to turn back to you. What makes propane appealing?
First and foremost, you're now dealing with a second gas versus a liquid fuel. So now if you want to run in condensing mode for hydronic boilers, there is no problem doing so. You don't have to worry about changing loop temperatures and everything else like that. Piping is simpler. I mean, you get a propane tank, you set it up for the pressure you want to deliver, and away you go. It's just like a natural gas system. Relative emissions are better. So you have the lowest fuel emissions right now is natural gas. I'm sure hydrogen coming down the road may have better aspects than natural gas. Then you got propane and you got diesel. So that's a performance improvement. And the BTU content of the fuel is 2.5 times what natural gas is. So you can actually consume less cubic feet of propane versus natural gas. And all the materials, everything you do for a gas system is no different than materials and design you do for a propane system. Northern climates might have an issue. Propane has a dew point as well. So whatever you're delivering into the building, I think it is, as pressure increases for your delivery, the dew point of that propane drops. The lower pressure, it's higher. So in cold climates, you may need some kind of vaporizer to maintain vapor propane for combustion versus liquid, because a liquid propane will do some pretty bad things to a burner as well. So yeah, the advantage being cleaner.
You've mentioned some performance improvements there. Are there any operational trade-offs on the back end?
Cost and delivery. Natural gas typically comes in a pipeline, and there's very little times you see interruptibility. I mean, yeah, we have hurricanes come through, or we have a transmission station that goes down. But I think over the last, I'll just go back like 10 years, I can think of maybe 2 instances where they told people on the Florida Gulf Coast, switch, your gas is out because something happened up in the panhandle, or there's been some outage from weather. Propane, you have to plan for delivery. There's how much you're going to burn, how often are trucks coming in to refuel, just like diesel. It's not a unlimited supply sitting in your backyard in those tanks. There will be some refueling.
So then, George, are healthcare facilities starting to use propane more? Are you seeing that becoming more common at all in Florida?
I haven't seen it yet. I'm expecting it, though. I think because the alternative is, as we mentioned already, the alternative being diesel fuel. So I am expecting this to become more of a norm once people realize the simplicity of it. There is the aspect of storage that now we have an extra tank, one or more extra tanks. Maybe they're a little bigger. Maybe this is a good time to mention that you would have extra tanks for diesel fuel as well,
right?
If you do the design the correct way of not mixing diesel fuel for your boilers and for your generators. This is a totally different discussion, and we would want an electrical engineer here involved, but it's not, they don't like each other. Diesel fuel for boilers and diesel fuel for the generators. The return of the diesel fuel from these two systems are not good friends, and could actually lead to some very serious events, environmental events that again, unfortunately, have happened in the past. So in that regard, having more tanks does apply to both systems. The size of the tanks may be a little bigger on the propane, but I do expect that to become more of a norm.
So you mentioned some environmental impacts, of course, just now. There's a lot of talk recently about decarbonization and how healthcare systems are under pressure to decarbonize. But from what I've gathered here, boilers sound like they're pretty foundational infrastructure. So my question is, how realistic is full electrification, especially in a place like Florida?
I would say it's not. I have been over the last couple of years, I've been a part of several presentations by different manufacturers. So this is not anything to do with what I sell. And both of those gentlemen who presented had a national grid up there. And there's a factor, they had a scale on the right-hand side, and there was a breakpoint factor called 1.4, 1.41, and that's the cleanliness of the grid, how the energy is produced. And if the grid production is fossil fuel drives that production above the 1.4 line, it makes no sense to go electric, because you're actually producing more greenhouse gases and burning fossil fuels to produce the electricity, to transmit the electricity.
And you are reducing your footprint.
You'd be better off firing the fossil fuel at the site and dealing with those emissions locally versus at the power plant. There's also the capacity issue of the grid. And then, as I said before, I've been involved with, and this is in the past 3-4 years, food and beverage companies deciding, hey, we're going to go carbon free. We're going to get down to carbon neutral by such and such a date. So decarbonization is on one of their key goals corporately.
Yep.
We go through the exercise of, okay, this is what you need for a boiler. And they'll come back and say, well, what if that's an electric boiler versus a fuel fired boiler? And every time we've been through that, the ROI for going electric eliminates the whole going decarbonization. And there was, in the case of Boca Raton, it was almost 4x for energy use versus fuel. And then the infrastructure comes to the facility. And if they get the electricity there, now how are you going to handle something? It was like 3,000 amps. What do you do with that? And the facility manager, his hair was on fire when he saw those numbers. So there is a trade-off to go electricity. Now, if you're up in Washington State or across Canada and you got plenty of hydro, have at it. We just got back from Argentina last year, and I looked around. I'm like, where do you get your power from down here? And they said, it's all hydro. And I'm like, I didn't see any power plants as we're going through the country. So in their case, they got plenty of green energy where you don't have to worry about fossil fuels.
Interesting.
Unless your grid is built that way, it's going to take a long time to get green enough, just based on the things I've been reading, to produce that electricity 24/7, by the way. So solar's not the source, to produce that and decarbonize on a fossil fuel type basis.
So George, Rick just mentioned, there was a company or a corporation that had it part of their, goals. And we've got that internally too. We want to try to reduce the carbon footprint in the way that we design. Is this an evolution? Like, are people wanting this because they feel like we're evolving, or is this like a revolution,
I think it's an evolution. I think it's part of our of us doing the right thing. And I agree with everything that Rick said, and I know he feels the same way. So we're stating facts, we're stating realities, but we're not giving up on it. It's definitely something that we do take into account on every project, and every day. We have to be good stewards. We have children. We have to make sure that the safety and the health of our future generation, of our planet.
Right.
So we're not giving up on it. And that's, maybe a little bit of frustration when you go to presentations and you hear people being maybe ultra optimistic, because that could lead others, to maybe non-technical people, to think that not everybody's doing their job. No, we are doing our job. We're just being realistic, and we are looking for ways to improve, and we are committed to reducing carbon footprint as much as we can. And I think one of the keys is going to be electricity production, as Rick mentioned. Maybe it's hydro, maybe it's wind, maybe it's, I personally believe it's going to be some other source, whatever. I don't know if it's nuclear, but there's got to be some other source coming our way, as otherwise I don't know how, with population growth, I don't know how we can make this sustainable. So we keep this in mind, and we try to implement it as much as we can.
Really interesting thoughts. What's one question hospital facility leaders should ask about their boiler plant?
Ask about it as to how to maintain it,
you can pick whichever one you want. Should they be asking more questions about how to maintain it?
I think, educate themselves on water treatment, especially a steam plant now, because it's critical for operations. Also, George, you mentioned the skilled labor. You've got to invest in people that have we have technicians that work for us, and you can teach them combustion, you can teach them electricity, but there's still the aptitude that's not learned. They either got it or they don't, relative to stuff and stuff like that. So where to get trained operators, what are some resources out there to improve the knowledge of the operating maintenance staff to maintain? You want as much uptime as you can get out of your plant. And it doesn't matter what the brand of boiler is. If all the utility stuff coming to it's bad, it's garbage in, garbage out, right? You just got to maintain the uptime, and it takes people to do that. So resources, where can I get trained people, or what resources are out there to help educate my folks?
Yeah, I agree with all that. And I think I can maybe try to put it almost in one sentence. So one question rather is, are we getting the best balance of efficiency, reliability, maintenance, and cost? I think maybe 4 elements, efficiency, reliability, maintenance, and cost. And always keep in mind, for any big piece of equipment, its total cost of ownership, as we mentioned already a couple of times here. It's not the first cost. If you want to be proactive and improve your performance and minimize your costs, you have to look at the total cost of ownership.
And if I may, on that statement, George, we, as a company and the manufacturers we represent, we have something called a boiler plant optimization visit. They call it BPO for short. And it's safety, reliability, efficiency, and the fourth one, sustainability.
Oh, yeah.
So we actually go through people's plants free of charge and perform these BPOs and come back with, hey, if there's some safety issues, here's some things you can correct, Mr. Owner. That's not on us. But on the efficiency and reliability, there's some opportunities there for improving the plant operations, which lowers the fuel costs, which helps you decarbonize even.
Well, thank you both for coming on the show. I really appreciate it.
Thank you.
Thank you for having us, and I also want to thank Rick for joining us today. It's been a great supporter of ours, and his depth of knowledge is unmatched in my experience.
I'd like to thank Rick and George again for joining me on this episode of BSA by Design. You can connect with them each on LinkedIn. If you want to learn more about BSA and our engineering services, we encourage you to visit our website at bsadesign.com. There's a link in the show notes to contact us for more information. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. Be sure to check out BSA on social media, including LinkedIn and YouTube. That will do it for this episode. Join us again next time on BSA by Design.